Welcome back to CSC 143, Intro to Data Structures. Today I'm going to be talking about Chapter 10, ArrayLists. And every chapter I'm going to give a brief reminder to people in case you happen to be joining us now that CSC 143 is the second of two computer science courses taught at all Washington State colleges. And there are similar CS classes nationwide. We use the book Building Java Programs by Stuart Regis and Marty Stepp, version 4. We also use Practice It, which is online and lets us do all the problems in the book. So we are now looking at Chapter 10, ArrayLists. Today, in this lecture, I am going to be covering the basics of ArrayLists. So we're going to cover the basic operations, how it's different from an array, how we search. We'll take a look at an ArrayList program in Eclipse. We'll talk about how to add and remove items from ArrayLists and some of the pitfalls with that. Remind you about the for each loop and how it works with ArrayLists, and talk about wrapper classes as well. Let's switch over to Eclipse now. Before I talk about ArrayLists, let's remind ourselves about arrays with a simple problem here. This problem is a combination of fence post and sentinel loops, which you should know from 142. So what we're going to do is we'll prompt the user to enter a bunch of integers, and then we're going to use a scanner in a sentinel loop, repeatedly getting those integers until we hit the value 0. And then we're going to use a fence post algorithm to print out those numbers. So I've already started running it here. If I type 1, 2, 3, 5, 4, ending in 0, it prints those numbers out. So this is a great use of arrays, but there's some limitations. So for example, right here I've declared that this array only has 10 items. If I were to do more than 10 items, the program's probably going to crash or have some error because we're going to be writing items that don't exist. And I also have to keep track of, because I don't actually know how many items are really in this list, there is a .length function of arrays, but that would always just tell me there are 10 items, whereas I actually have to keep track of the count. So I've got a variable count that I'm incrementing as I go through the loop here in order to keep track of which items I've actually used in the loop. But other than that, this works fine. So now let's take a look at ArrayLists. We're going to look at ArrayLists mainly because this limitation here of 10 items is something that in real life you can't use. Okay, in class you can use 10 items. But in the real world, you can't restrict the user to a few items like that. You have to be able to grow that list to any arbitrary size. And that's what ArrayLists let us do. I'm using these slides prepared by my dear friend of over 30 years, Dr. Amelia Gahn. And these slides roughly correspond to the content of the Building Java Programs book. So we've got chapter in binary 10, and it's about ArrayLists. So as I was saying, the main reason we're going to be looking at ArrayLists is because they are dynamic. And I also just want to take a step back and say that ArrayLists are the first of many different classes that Java provides to us in what they call the Java collections. So this is just the first of many different types of data structures that we're going to be looking at. So ArrayLists, the difference between arrays and ArrayLists is that they're dynamic, they can grow and they can shrink, and we can get the size as it grows and shrink. So these classes are provided to us, and so the nice thing about all these Java collections is that we don't have to know how they're implemented, we just have to know how they're used. But we will be talking about how they are implemented so you understand them better. ArrayLists they automatically resize, and so it makes it a very flexible class, which is it's generally more interesting to use the ArrayList class than the array class, but it's also less efficient to use the ArrayList class. You'll understand that better as we take a look at a full example of why that is. The great thing about ArrayLists is that they do use an array internally, so when you go to look up an item in the array, it's the same fast random access that you're used to from arrays. However, when you are adding elements to an array list, if you stick it at the end, it's quite efficient. But if you stick it into the middle or the beginning somewhere, you have to shift all the items down, and that shifting can be fairly time-consuming. So the ArrayList is the first of the Java collections classes, and we have to introduce a new concept to you that's going to be used throughout the Java collections, and that is the concept of parameterization. So you can handle an array list with all sorts of different types. You can handle it with integers, strings, characters, booleans, just about anything you want. And in order to do that, Java has a syntax with these less than, greater than signs, okay? And this is called parameterization. And I especially emphasize that term because you will get syntax errors, and it'll mention parameters or the parameterization, and so you need to understand it's talking about what goes inside these brackets here. So when you actually declare an array list, you actually put the type that you want to make that array list inside these angled brackets here, and then this is actually part of the type then. So this is not just an array list, it's an array list of strings. And so you should always think of this entire thing, the array list and the string in the brackets, as the type. And if you do that, then it doesn't look so strange. Just like you would say an int x, okay, equals, and then you would declare what it is, or really a string would be a better example because a string is a real class. So you would say like string s equals new string, open paren, close paren. Okay, so this is a new terminology that you have to get used to, but you're going to be using it throughout all of the Java collections classes. So this is a parameter, and the parameter that we're supplying is string in this case. There is a note here that in Java 7 and beyond, they have what's called the diamond operator. So in this case, you're always going to have this parameter here on the left-hand side and on the right-hand side. So they allow this shortcut where you just use the diamond operator. Personally, I think for new students, it's a bad thing to learn because you're still getting used to it at all. So adding this thing in here doesn't really help you. You need to have practice typing in those parameterizations so that you get used to it. Later on, it's perfectly fine to use the diamond operator. We just talked about parameterization, and anytime that you provide one of those parameterizations like string, you need to use an actual class. So there are primitive types that Java has, which we learned about in 142, like int, and with a lowercase I, and a double with a lowercase d, and a char, and those are the primitive types, okay? But because in the parameterization we need to use a full class, we have to use what's called wrapper classes, okay? So these look just like the primitive classes, but they're slightly different. So it's capital integer, it's capital double, capital character, capital boolean. And these are just wrappers around the primitive classes so that you can use them with parameterized types, such as what we're dealing with the array lists. Just have one last slide to show you before we actually take a look at some code, and I think things will solidify from that. So there are methods on the array list. Again, so that's one of the differences between using an array, where it's just a primitive type, and you have just very basic operators, such as indexing, and this is an array list as a class. So now you've got actual methods. You're going to call dot add, for example. So you can add a value, and it'll just stick it on the end of the array. So that's different than when you index into the array. You have to keep track of what is the last item to put it at the end. So you don't have to provide that anymore. Or if you do want to put it in a particular place, or you want to provide the last index, you can provide that here as an overloaded form of add. You can remove all the items. You can get an index. So whereas with a regular array, you can just index into the array using the square brackets. You can't do that now. You need to use a get index. You can remove an index, but be careful. We're going to talk more about this later. But when you remove an index, all the other further indexes are going to shift down one. So you have to be careful of that. And you can also set, and so this will replace the value without shifting everything. And there's a whole bunch of other operators as well. So now let's go and take a look at some actual code. So let's go about changing this sum ints from using primitive array operators and primitive ints to using the Java Collections ArrayList class. So the first thing you have to make sure is you have to import Java util. and that'll bring in the ArrayList class. So then let's replace this line here with the ArrayList version. So that's going to be ArrayList of integer. Okay, so not int, but capital integer. And this is the wrapper class for integers. And again, so this, we have to think of this whole thing here as the type. So this is like int brackets. And then we have to still provide the name of it. So let's still call it nums equals new ArrayList of. Now, remember, you could use the diamond operator, but I think at this point, people should be writing everything out so that they're used to it. ArrayList of integer. And we aren't going to give a size because by default it's going to have 0 elements, and we're going to be adding elements. So that's another difference from using integers. We don't have to tell it how many items we have. Okay, so and previously we needed this count variable, and that's because we needed to know exactly how many elements were valid. So we don't need the count anymore. We're still going to create the scanner. We are still going to get the next integer. We are still going to have the sum. And we're still going to check to make sure that number isn't 0. But now we need to change this. So let's comment this line out and change it to be. So we're going to actually have to use the set method. So nums.set, and there's 2 different forms here. We can either use give it the index and the element, or we can just give it the element. So in this case, we're going to give it num. That will put it at the end of the list. And let me just quickly check. That is right there. So it's not applicable for the arguments of int. So it should be converting. So this is one of the things that Java should do, is it should convert. If you give it an int instead of an integer, it should convert the int to an integer. I think once we start writing the rest of this code, it should be happy. Okay, so we're still going to sum it up. We're still going to get the next int. And then down here, so we can't directly index anymore. So now we need to do nums.get at the index 0. And then here, we no longer have count. Instead, we are going to look at the nums.size, not length. Dot length is just a primitive property. Dot size is a method on the ArrayList class. And then we can't directly index anymore, so now it's going to have to be nums.get of x. Okay. I just realized you can't use set. Set is going to require the index, so we're going to just do add. That's what we want. We're going to add it to the end of the list. Okay, so we're going to add that, and I think that should work. So let's try running it and see what that looks like. So first I'm going to run it just like I did before. 1, 2, 3, 5, 4, 0, and it works. But now let me try, at this point, let me actually debug it, and I'll show you what is really happening here, because it is slightly interesting. So I'm going to run debug, and it's going to, let's step into this routine, and we're actually gonna, I think I'll just jump because I've actually got another breakpoint set. I'm gonna enter in 1, 2, 3, 5, 4, 0, enter. Okay, so I'd hit a breakpoint that I saved down here. I've got a visualizer in here written by former UW person Adam Blank. He's now at Caltech. And so he's got this visualizer that shows you what is actually going on with your memory. So nums is an array list of integer, and its size is 0. And you might be wondering, well, where are all the items? There are none, because when you initially declare this array, it just says there are 0 items. It never actually allocated any space. But let's go ahead and step through here, and let's add the first num in, and you might have seen it right there. It added the first num. Okay, and then it's going to go and it's going to add the second num. And let's take a look. Let's scroll over here. You see that there are actually 10 items that it already pre-allocated. Let's go ahead and go through the third item. So it's got 10 items here, and I'm actually going to jump to the end of this. And so now it's entered all the items. Okay, so there were 5 items. It didn't need these last 5 here. Okay, so now I'm going to stop it, and let's try it with 10 items. Okay, so I'm going to run it, debug it again. And I'm going to jump to the same breakpoint. So I'm going to enter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers. And let's again go to the breakpoint, look at the visualizer. Okay, so the array list of integers, it says the size is 10, and it filled out all 10 items that were previously allocated. So this is perfect, okay? But what happens if we go to 11? Let's go ahead and stop this and debug it again. And I'm going to step over these breakpoints. And I'm going to enter in 11 items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, you might be thinking it's going to expand, right? It's going to expand to accommodate 11 items. And the other question is, why did it have 10 in the first place? It's some arbitrary number. They wanted to give some room to add numbers without having to reallocate it again, but 10 was the default, and so now we're going to need more than 10. So let's see what happened. Okay, so now we got the 10 numbers, 11 numbers, and you can see it actually added 5 more items. So it won't have to reallocate until 5 more items get added in here. But there is a little bit of inefficiency because it has to allocate extra items that it doesn't need. And if you were to shrink it, it would be fine. It could shrink it down. I'm not sure at what point it might actually reallocate this or not. But I just wanted to show you what's happening behind the scenes of this thing. Now, there are a couple other methods that the book talks about which are useful and worth talking about to show the power of array lists. So right now, if I entered in duplicate numbers, it would just store those in the array. But let's suppose we didn't want to. If we were using a regular array, every time before we would add the number, we would have to go through and look at, we'd have to have a loop, all right? We'd have to loop through all elements to check for dupes first, okay? That would be a loop. It would be a bunch of code that we'd have to write. Not very hard, but we would have to do that. So there is a method that you can use on the array list to do this for you. We can say if nums dot contains num. So if it contains the number, so it is a duplicate, and we can say equals false, then add it. Or actually, we could break. We do that probably better because then I don't have to worry about the rest of this. So if it is, we just break. That's going to jump over all the rest of this code, and well, actually, we can't jump over all of it. We're going to have to. No, okay, let's do this. Equals false, because we need some of this code. We're going to have to add the number and sum the number, and then here, that'll do it. So if it's false, it's just going to get the next integer. Okay, so let's try running this. We're not going to debug it, we're just going to run it. Let me show you the console output though. Okay, 1, 2, 2, 3, 3, 5, 3, 3, 4, 0. Actually, let me add a couple more numbers in here so you know that it's exactly different than our input last time. 1, 2, 3, 5, 4, 6, 7. So it skipped the duplicate 2, it skipped the duplicate 3. So yes, this code does work. Another thing you can do is you can get the index of. I'm not going to write the code here, but you could say if index of num and then equals -1. That should do the same thing. So this means it can't find that index. There's also a last index of, in case last index of, in case you want to look at the last one, so the first one. So let's try running that. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 0. Okay, so it skipped those the extra 1, 2, 3. Okay, so those are some of the most common methods you're going to use on ArrayLists, and I've tried to show you how using an ArrayList is different than using an array, and also what are some of the benefits. In particular, in the real world, you're going to want an array that you can expand and contract. And I've also shown you can use some nice features to look through your array, which you can't normally do without having to write code yourself.
I just thought of another thing that we can do with the ArrayList class that we couldn't do with the primitive arrays class. So down here, I'm using a fence post algorithm to print out the results. Some of you may have realized you could have also done a arrays dot toString and then given it nums. That can work, but I'm going to show you a different way. So the arrays is a class, right? So now we actually have an ArrayList class, so we can do this. Let me take this, and we no longer need to put the open bracket in there because the toString for the ArrayList will do it for us. We're just going to put nums here. Oh, we can explicitly say .toString just so you understand what exactly is going on. And let me comment this out here. So now when I run the code, 1, 2, 3, 5, 4, 0. Now you notice that there, so that this is now calling the nums.toString here. Before I had been using just a comma, no space. So the toString, unfortunately, or fortunately, includes a space. I actually don't think that's the best thing to do because toString, you really want it compact. But anyways, that's yet another thing you can do with a class that you couldn't do with just the primitive arrays. I just wanted to point out that that change wasn't entirely successful because I forgot that I was actually creating the sum and I was printing out the sum, so I'd have to also print the sums to blah. In fact, let's go ahead and do that just to make it complete. There we go. Let's try that. 1, 2, 3, 0. Okay. Now I want to talk about the next section in the book, which is adding to and removing from an array list. So let's suppose that we want to put a 0 before each of these items. So we want it to say 0, 1, 0, 2, 0, 3. Don't ask me why. We're just going to illustrate this. You frequently do want to insert items, okay? So that's the point. But I want to show you the problem with when you insert items. So a simple way to do this might simply be to insert a 0 before each item, and then for int x y equals, we're going to start at index 0. While I is less than the nums.size, and we'll increment, and we'll do a nums.add, and we want to do the form. Let's take a look at the help again. Nums. It's not going to give me. Let's try this again. Nums. There we go. And then there's add, and there should be another add. Here we go. Index and element. Okay, so the index will be I, and the element will be 0. Okay, so we're going to add 0 before each of these numbers. Let's try running this. 1, 2, 3, 0. Okay, that didn't work. So I notice as I'm continuing to add items, it's not that we're not hitting 0. The problem is that this loop is never finishing. And the reason why the loop is not finishing is because I'm using nums.size. Okay, this is part of the problem. not part of the problem I was trying to show you, but it's part of the problem, which is that because it's a class and these are methods, it gets updated every single time you look at the class. So after I've finished here, the size is going to be, the size will be 3, okay? But as soon as I add one, the size becomes 4. And then I add another one, it becomes 5. And so we never hit the size. So let me quickly try to fix this, not so successfully. And I'll say int s equals nums.size. Okay, so now what this is going to do is this is going to grab 3 at the start of the loop, and then it should terminate. So let's try running this. 1, 2, 3, 0. Okay, so it terminated. But what is this? It added all the zeros at the beginning and not in between the items. So this is the problem I was trying to show you, which is that, again, whenever you call one of these methods, it's dynamic. So it looks at whatever the array looks like at that particular moment. And in fact, this might be a good opportunity to set a breakpoint and go into the debugger. Let me clear out a couple of these other breakpoints. And we'll use the visualizer. I'm going to slide this guy over. And let's go out to our breakpoint. So we're going to enter 1, 2, 3, 0. We hit the breakpoint. Here's the visualizer. So you can see we've got elements 1, 2, 3. And now let's step through this code. Hit F5 to step into the code. So it's going to add at I, which is 0. It should, yes, I equals 0. So it's going to add a 0 right before the 1. Okay, that's exactly what we wanted to do. Now, let's step through the code again. So now I is equal to 1, and it's going to add a 0 at position 1. Well, what is position 1? See, position 1 used to be between the 1 and the 2, but it's no longer going to be the case. So now it's going to add it right here again. It's going to slide all 4 of these down. Let me step, and there we go. Switch back. So yes, it's doing that. And it keeps on adding 0 at the 0th position and sliding all of these down. So that is not what we want to do. So we can think about how to fix this. So if we added 0, let's forget that this one's here. We added the first 0, and we want to put it not at position 0 anymore, not at position 1, but we want to put it at position 2, right? And then when there's a 0, 1, 0, 2, we want to put it at position 0, 1, 2, 3, 4. So it looks like we need to add 2 each time, 0, 2, 4. So let's change this to I plus equals 2. And then we're not going to debug it. We're just going to run it now. Okay, let's try 1, 2, 3, 5, 4, 0. Okay, so that did 0, 0, 0. However, it didn't go all the way. So the nums size should have been 1, 2, 3, 4, 5. So it inserted it up to element 5, right? But not the total number of elements. So that's yet another problem. So let's see, if we continue to look at the nums size, I think this might work. Let's try it. Let's see if we can actually run it correctly this time. 1, 2, 3, 5, 4, 0. Okay, it did work correctly this time, and that's because we're now adding the I plus equals 2, and so every time we're adding 1, but we're skipping 2 ahead. So that did the trick. There are other ways to do this though. So let's go back to, let's see if I can go back to what I originally had here. Let's go all the way back. Okay, and set it. Okay, so here's the point where we're just about to create the elements. So we want to add, let me actually comment this out and run it again just so we can see it. 1, 2, 3, 5, 4, 0. Okay, so we want to add elements in between a 0 before each of these numbers. What if we start from the end? So it'll be item 0, 1, 2, 3, 4. Okay, so 1 from the length. So if we start at 4, then we come back. Because we've shifted this only this item here, this one is still correct. So we want to put the item at 0, 1, 2, 3. And then we'll shift those down. It'll be a 0, 4, 0, 5. But we aren't going to touch any of those. Now we're going to be putting it at element 0, 1, 2. So we went 4, 3, 2, 1, and then 0. So it should actually work. So let's instead try this. And let me uncomment this. I still want to... now I can actually start at the nums.size. And the reason I can start at the nums.size, not have to save the numbers, is because it's only going to evaluate this once. In fact, that's oftentimes a good reason why you want to decrement rather than increment, because you only have to evaluate this function once. So if it's at all expensive and it doesn't change, then it's always better to do it to start and then you decrement. So now we're going to have to change this to be I is greater than or equal to 0. And then we're going to decrement I. Okay, and then we're going to add I, that's correct, and the element is 0, that's correct. Okay, so let's try running that. 1, 2, 3, 5, 4, 0. Okay, so almost right, except 3, 5, 4, except we had the 0. Remember I talked about when I ran through the scenario, I told you that we have to start at the size minus 1. And I forgot that myself, so let's try that. My bad. But that process that I went through of looking at the first few elements and trying to see what the index are, that's a very important and powerful way to make sure that your code is correct. You want to simulate it before you actually do it. So what we've learned is that when you add items to an array or when you delete items from, oh, actually we haven't covered deleting, but it's the same problem in deleting. Let's go and let's print it out and then let's try deleting now. Okay, so let's delete them. So the simplest way, let's start out again. For int I equals 0, while I is less than nums.size, I plus plus. And so we're going to do a nums dot, should be a delete. Or remove. There it is, remove. Remove at integer. Okay. Put that in. Okay, so items remove at index I. Okay. So, and then we want to skip every other one. So let's try plus equals 2. I'm not saying this is going to work, but it will be our first pass. Okay. So we're going to try to remove starting at 0, skipping every 2, going up to the end. Let's see whether this works. It might. Let's see. Oh, I forgot to print it out again. Okay, let's try that again. Okay, so other than the fact that I forgot to actually do a println instead of a print, easy enough to fix. You entered 1, 0, 0, 3, 5, 0. So it didn't work. What did it do? It removed the first one. Okay. Then it was trying to, instead of index 0, it's trying to remove index 2. But in the new array, it was 1, it started at 1, and then 0, and then 2. So this was index 2. So that's why the 2 disappeared. So again, the array is changing on us. So when we delete item 0, we no longer want item 2, we actually want item 1. And then let's think about this. So I don't think I can't really just type it in here, but I could type it in here. So we go from 0, 1, 0, 2, 0, 3 to 1, 0, 2, 0, 3. Okay, so here we want to remove item 0. Here we want to remove item 1. Then it's going to be 1, 2, 0, 3. Here we want to remove item 2. So it looks like we don't have to step twice. We want to step just once. So let's just change this to plus plus. 1, 2, 3, 5, 4, 0. There we go. That worked correctly. And again, let's take a look at doing it backwards. Can we do it backwards? Let's change this. And let's try it. I'll just do it down here. So now I'll simulate it so we can see what's going to happen. 0, 1, 0, 1, 0, 2, 0, 3. If we remove from the end, so we are going to remove 0, 1, 2, 3, 4. We're going to remove element 4, then it'll be 0, 1, 0, 2, 3, and then we're going to remove element 0, 1, 2, and so then it'll be 0, 1, 2, 3, and then we want to remove element 0. So we're going to go from the end, we're going to take off, subtract 2 each time. So for int I equals nums.size, while I is greater than or equal to 0, I decrement, just a single decrement, and then we're going to do a nums.remove of I. And it's complaining because I didn't put the semicolon in. And then I've still got the same println, so this should work. Oops, not quite. Okay, so we have a range check, so an index is out of bound. The index is 10, and it looks like it was calling it from line 47. Okay, so it's going to start with the size while it's greater than or equal to 0, and it's going to remove the item there. So it's going to start at 0, 1, 2, 3, 4. Okay, so it's going to take 4, and then it's going to go to 3. 0, 1, 2, 3. Oh, so I think I said it was actually 0, 1, 2, 3, 4, and then 2, and then 0. So actually we need to decrement by 2 each time. Okay, let's run that again. 1, 2, 3, 5, 4, 0. Okay, still didn't work. Size is going to be 0, 1, 2. Okay, so we're going to start out with 0, 2, 4. Oh, you know what the problem is? I started out with the wrong number. Okay, so the size here is 1, 2, 3, 4, 5, 6, for example. But we are actually looking at 2 back. So we're going to take size minus 2, and that's what the problem is. 3, 5, 4, 0. There we go. Okay, so a couple of tricky things in there. First, you got to always make sure you figure out what is the place you're going to start at. Okay, in this case, it was the size minus 2. And then you got to figure out what you're going to count down to. And then you got to figure out how many you're going to subtract off each time. But if you do all of those, you can get it. You can see that going backwards is somewhat similar. If you work it through, it's not a whole lot different if you then going forward. But either way, you can decide how you want to do it. So we've talked about the dangers of adding and removing from an array list. Another thing that there's a precaution against is you can, let's see, where am I doing this here? So here's, yeah, I don't have an easy place to do this. So there's a for each loop. we can comment this code out. So there's a for each loop, and we can say int y in nums. And what this is going to do is it's going to look at every single, it's the exact equivalent of doing a for loop where you're setting int y on index 0 till the size. Okay, but then if you try to do a nums.remove on, let's say, item 0, it's not going to let you do this. I don't think this is a compile time error. Yeah, it's not a compile time error, but it's going to be a runtime error. So check for co-modification. So you cannot, inside a for each loop, actually modify the loop. And there's more information on this later when we talk about how iterators actually work. This is actually an iterator, and you can't have the underlying object of an iterator change on you. But just remember that that's a restriction on removing items from lists. You can use for each when you're adding items. Actually, not sure you can add them either. Let's just try this. This is going to be bad because you'll never end. Well, I wouldn't try changing anything, okay, when you're doing a for each. So those are precautions when you add or remove things from a for each loop. And that's another section in the book. And then the book also talks about wrapper classes. We've talked about how to use wrapper classes already. So we have this integer here. So what happens if let's talk about errors for a second. Let's say that you forget to use any parameterization. You just put ArrayList. The error you're going to get specifically says ArrayList E should be parameterized, okay? So that's the first thing. But if you put in a regular type, primitive type, it gives this very confusing message about inserting dimensions. Basically, it's saying that it's not happy with this here. And unfortunately, it's not a better message. So remember, you need to use a wrapper class for integer. So you've now learned everything you need to know in order to try out practice it problems for section 10.1. So both chapter 9 and 10, unfortunately, do not have the full list of all the problems. In the book, there are 18 problems in section 10.1 and exercises. Actually, the exercises aren't broken out, but there are some 20 exercises. So you can see that they're about half the exercises, but only maybe about a quarter of the self-checks. But I'm going to go through a select number of these and just kind of give you a few hints about what to think about. So this one is pretty straightforward. You just need to verify what is the correct syntax. And remember that on these parameterized types, this type inside these braces here is part of the type. Okay, you can never use just ArrayList on its own. The type is ArrayList of integers. Okay, max length. So you're going to take an array list of strings as a parameter and return the length of the longest string. So you're going to have to iterate through all the items in your array list and keep track of what is the longest string by some method. And this is really just basic, getting you used to going in and getting the items. Remember that there's a get method and looking at the values and then finding the minimum. All right, I don't particularly love ArrayList mystery, any mystery problems, but you can try a few of these. Notice, of course, that when you're adding items, that the indexes are going to change. So that's the main thing they're trying to get at here. How do you keep track of the indexes when things are changing? So swap pairs, there's a list of pairs that they're giving you here. Here's a pair, here's a pair, and here's a pair. And then what they want you to do is swap the pairs. So it'll then be score 4, 7, and ago years. So you're going to have to, of course, iterate through this array list, and you're going to have to figure out a way to swap the pairs. And there's really two ways to do it. You can either use the ArrayList.set method. So set will go in and change these values without moving anything, shifting anything. So that's kind of the safest way to do it. Or what you can do is you can remove an item and then insert it. Okay, so either way, but you're going to need to step down the list, probably want to step down it by pairs, and do those swaps. remove even length, so you're going to need to go down the array list, and any of the items that are even length, you're going to need to remove. And so, of course, remember that when you remove an item, all the indexes change. So perhaps you might think about going backwards, or if you go forwards, you just have to take that into account. Remember that when you're using a for loop with an index, you can actually modify that index in your loop. You can manually add one or subtract one as you need. That's going to be an important thing to do in this chapter if you decide you don't want to go backwards. Double list. Replace every string with 2 of that string. So again, you're talking about inserting strings into the list. So you need to be aware that these things are going to be shifting, and the same precautions as I've talked about. And min to front. Okay, so this one you're going to be iterating down the list and looking for the minimum. And that's similar to a problem we did earlier when we were trying to find, I can't remember if it was a minimum or maximum value. But now what you need to do is you need to keep track of that. Okay, and so obviously you're going to need to keep track of the index of that item. And then you're going to need to insert that, or add it, I should say, at the head of the list, I believe. So you just have to keep track of what the minimum index is and then be able to add it. Removing duplicates. So we want to go through and remove all the duplicate strings. So I think that these are sorted. Yes, it takes a sorted, and that's key. So if it wasn't sorted, you could use the ArrayList .contains method, but you don't need to do that. You instead should just be looking at the previous and or next item in the array. So as you're going through this, whichever direction you're going to step through it, you just keep track of the previous one and the current one, and then you can take your actions based on that. And of course, again, remember, since you're deleting items, you need to either manually change your index that you're working with, or you need to step through it in the correct direction so that you don't affect anything that that you've already looked at. Remove in range. This is a little bit confusing terminology. So they're going to give you the range is a starting index and an ending index. So it's going to give you some subset of this array to look in, and then it's going to get an element value. And they want you to remove that element value from a certain subset of the range. So you need to be stepping down this list, and you need to be checking your index to see whether you're in that range of indexes to look at. Then you're going to check a particular value. So same precautions apply. If you step forward, you need to make sure that you adjust the indexes if you remove something. Otherwise, you could step backwards. This one is politically incorrect, so I'm not going to talk about that one. Let's try mark length 4. So every string in here that is of length 4, you want to mark it. It would be easy if it was actually changing the string to add the 4 stars, but they actually want you to insert an item. So that introduces the same complexities that when you insert an item, you have to manually adjust your indexes, or you could do it going backwards. Remove shorter strings. Okay, so this is a bunch of pairs again, same sample that we used last time, and whichever is the shorter item needs to be removed. Nothing too different about here. You again are going to be doing the same type of work, same precautions. Filter, okay, so filter range. So we had a range problem before, but the terminology is different here. So now the range refers to a min and max value. So any items in the entire list that are within that minimum and maximum value are going to be removed. But other than that, it's pretty much the same kind of work. Again, you're looking down this array, you're going to remove any elements that fit in that range. Interleave, I'm going to skip this one. Comparable point, I'm going to skip this one. These are all fairly complex ones, and I'm not going to cover exactly how to do. But from looking at the other problems, basically you're looking at a couple of things. One is, are you familiar enough with the ArrayList class in order to be able to use methods like get, like remove, like add, and are you comfortable dealing with adding and removing items while you're stepping through a list? Okay, and I would suggest you actually try going forward problems and going back in some problems and see which you like. When you go forward, you're just going to need to play with your indexes so that when you add an item, maybe you have to skip ahead. When you delete an item, you reduce it, whatever you need to do. So try it both ways and see what you like. So should be a very good preparation on section 10.1. And if you've liked this video, please like and subscribe. My next video in this chapter is going to be talking about the comparable interfaces. And yes, look for that video.